A rectangular gasoline tank can hold 50 kilograms of gasoline when full. What is the depth of the tank if it's zero point 0.5 meter wide by 0.9 meter long? And we know the mass of this tank, and we know the two dimensions of the tank, and we can use the density formula to calculate the volume of um, this tank. And so if you just remember density formula, so density equals to mass divided by volume. And so we know the density of the gasoline, and we know the mass. We can figure out the mass. We can figure out the volume of this tank. And if we just use the cross product, so the V will be M divided by rho, and the mass is 50 kilograms. And if you just search online, what is the density of gasoline in terms of kilogram per meter cube, that is 680 kilogram per meter cube. And so we're going to just divide 50 by 680. And let's just check the unit. So the unit will be kilogram divided by kilogram per meter cube. And so we're going to just use the first one is the same, and we're going to flip the second one and multiply them. And we're going to get kilogram cancel, and the unit will be meter cube. And if you just divide these values, so we're going to get 0.074 meter cube will be the volume. And also, we know the volume in terms of its dimensions. It's going to be L times W times D. Now we know the V. We use the density formula to calculate the V. And we know the L. We know the W. They are given in the problem. We can find this D using this equation. And so if you just isolate the D, so D will be V over L times W will be D. So the D equals V divided by L times W. V is the volume, that's 0.074 meter cube, divided by 0.9 meter times 0.5 meter. So if you just divide this numeric, so it's going to be 0.074 divided by 0.9 times 0.5. And let's check the unit. So the unit will be meter cube divided by m squared, right? We have an m here, another m. We have m squared. And so this is going to be canceled, and we're going to get the m in the numerator. So the result will be also, correct dimensionally. And if you just divide this value, the result will be 0.163 meters. Part B, discuss whether this tank has a reasonable volume for a passenger car. So to discuss about this, that's part B. So we have a volume in terms of meter cube, and let's just use the fact how we're going to convert this meter cube to gallon, that we can just get information about that if this is a reasonable the tank. So 1 meter cube is equals to 264.172 gallon. And if you just use this fact to get a conversion factor, and our conversion factor, which has meter cube, will be in the denominator to convert this volume into gallon. And so our conversion factor will be 264.172 gallon divided by 1 meter cube equals 1. And our volume is 0.074 meter cube times 264.172 gallon divided by 1 meter cube. Meter cube cancel. So the volume will be 19.5 gallon, which is a reasonable, tank for a passenger car.